All right, how's it going, guys? Today we're going to be going over module 7.1 to 7.2, day 2. Okay, on the top of your notes, we have this little paragraph that says verify polynomial identities. All it's really saying is that we do have polynomial relationships, and they're example of polynomial identities. And what we're going to be doing is that we're going to be using what we learned in the last video in the 7.1 to 7.2 day 1 notes to verify these identities. We're going to be using multiplication of polynomials and the addition and subtraction of polynomials to verify that these polynomial identities are actually true. And when we're verifying polynomial identities, we can only work on one side of the equal sign, okay? We cannot work on both sides. You're going to get a whole mess. You only want to focus on one side. And you're going to want to choose the side that we can actually do something to. Like, for example, on number 1 over here, there's not a whole lot we can do with 4ax, right? We can't really play with it all too much. So instead of like messing with the right side, we're going to work with the left side. Because with x plus a squared minus x minus a squared, we can FOIL that out, and we can play with it to maybe get it to equal 4ax. So let's go ahead and actually work it. For x plus a squared minus x minus a squared, we can actually see that both of these are the factors of perfect square trinomials, right? A plus b squared, that equals a squared plus 2ab plus b squared. At the same time, a minus b squared equals a squared minus 2ab plus b squared. These are our two perfect square trinomials. It's what we learned in module 6.5. And we can actually use these to help us FOIL x plus a squared and x minus a squared much quicker. You don't have to use these if you don't have them memorized, but they are extremely helpful, and it will help us in the next section. Okay? So for x plus a squared, whether you FOIL it out or use your identities, you will get x squared plus 2ax plus a squared. And we're going to minus x minus a squared, and when you FOIL that out or use your identities, you should get x squared minus 2ax plus a squared. And this should all equal 4ax. Okay? So what we're going to do now is we're going to distribute that negative into a second polynomial, and then we're going to add like terms. So let's go ahead and bring down the first polynomial, x squared plus 2ax plus a squared. We'll distribute that negative, so we get negative x squared plus 2ax minus a squared, and that should all equal 4ax. Okay? So now that we distributed the negative, we want to add like terms. So for x squared, we have a negative x squared plus negative x squared gives us a 0, so they just cancel out. 2ax and positive 2ax gives us 4ax, so we can write that down and cross it out because we used it. Now a squared and negative a squared, those cancel each other out as well, and we get 0. So we're left with 4ax on the left side, and that should equal the 4ax on the right side. It does. So we put a little check mark next to it, showing that we did prove it and that this polynomial identity exists. Okay? So for number 2, we have a plus b multiplied with a squared minus ab plus b squared, and that should equal a cubed plus b cubed. That's another polynomial identity, and we're going to prove that it's real. Okay? So what we're going to do is we need to choose a side that we can actually work with. On the right side, a cubed plus b cubed, there's not a whole lot we can do with that, so we're going to use the left side. Because on the left side, we have two polynomials being multiplied with each other, we can multiply them together, and we can add like terms to hopefully get a cubed plus b cubed. So let's go ahead and multiply horizontally for number 2. So we're going to take that a, and we're going to multiply it with every term in the other polynomial. So a times a squared is a cubed. A times negative ab is negative a squared b. And a times b squared is positive ab squared. Next, we're going to do the same thing with the b. We'll multiply the b with every term in the other polynomial. So b times a squared is a positive a squared b. And also on this note, it's always good habit to write your variables in alphabetical order. So we're always going to put our a before our b. So b times a squared is a squared b. B times negative ab is negative ab squared. And b times b squared is a positive b cubed. And we want all this to equal a cubed plus b cubed. So now we're going to add like terms and see what we can cancel out, what we can combine, and see what we get. So we start with the a cubed. We don't have anything else to add to it, so we can write it down, and we'll cross it out since we used it. Now we have negative a squared b, and we have a positive a squared b right next to, or later on in the equation. If you add them together, you get 0. They cancel out. Next, we have ab squared, and we have a negative ab squared. If you add them together, they cancel out, and you get 0. And lastly, we have b cubed. We don't have anything to add to it, so we'll just bring it down. And we're left with a cubed plus b cubed on the left side. And that should equal a cubed plus b cubed that we started with. It does. We put a check mark next to it. We're good to go. We've proven that this polynomial identity does indeed equal a cubed plus b cubed. Or we've proven that this polynomial identity is true. Okay, I'm going to do one more. I'm going to do number 3. I'm going to show you a little different way to do it. I think, well, you're going to see what we're going to do right now. Okay, so for number 3, what we're going to do is we're going to multiply out these 2 polynomials on the right side. Okay, there's not a whole lot we can do on the left side, but there's plenty we can do on the right side. And what we're going to do is we're going to use the box method. Okay. And remember, if we're multiplying polynomials with the box method, what we should do first is see how many terms are in each polynomial. In this case, we have 2 and we have 5. So that means we're going to have a 2 by 5 box. So let's go ahead and draw our box, make it pretty big, and we're going to make it into a 2 by 5. Let's actually just add another row right here. Give us plenty of room. Okay, so now that we have our box, our rectangle, we can go ahead and put our polynomials on each side of the box. So on the left side, I'm going to put a and negative b, and on the top, I'm going to put a to the 4th, a cubed b, a squared b squared, a times b cubed, and b to the 4th. Okay, now we're going to fill out this box row by row. For the first row, a times a to the 4th is a to the 5th. Then we get a to the 4th b, a to the 3rd b squared, then a squared b cubed, and then a b to the 4th. That's the first row. And for the second row, we'll have negative a to the 4th b, negative a cubed b squared, negative a squared b cubed, negative a b to the 4th, and negative b to the 5th. Okay? So that's our box. And what we can see, it's actually kind of cool with this box, is that all these diagonals end up canceling. If you add them together, they give you 0. Right? A to the 4th times b, added with a negative a to the 4th b gives you 0. A cubed b squared plus negative a cubed b squared gives you 0. A squared b cubed plus negative a squared b cubed gives you 0. And a b to the 4th plus negative a b to the 4th also gives you 0. Right? All those canceled out. So we're left with a to the 5th and negative b to the 5th. So our answer, or sorry, what we're left with is a to the 5th minus b to the 5th, and that's exactly what we wanted from the beginning. We wanted that polynomial to reduce down into a to the 5th minus b to the 5th, which is exactly what we got. So we'll put a check mark next to it. We've proven that this exists. Okay, now for number 4, I'm actually going to leave this for you guys to do on your own. We post the completed keys online, so you can try it. You really should be able to double check your work, since this side right here should equal the right side. If you multiply correctly and you added like terms correctly, the left side should equal the right side. That's your way of checking yourself, okay? But if you need help, we're going to post the completed key online through Canvas. So now that we've went through proving or verifying our polynomial identities, what we're going to do now is we're actually going to use them to help us solve problems. Okay? For number one, we have the identity x plus y squared equals x squared plus 2xy plus y squared. That's our perfect square trinomial that we learned in module 6.5. And we're going to use it to help us solve for the square of 27. Okay? And what we're going to do is we need to choose an x and a y term where the left side of this identity gives us 27 squared. Or in other words, we need an x and a y that add up to 27. Okay? And at the same time, we're doing this to make our lives easier, so we want to choose an x and a y that if we take the square of those numbers, it's easy to find out, right? So it's going to make a little more sense when I actually do the problem. But for this case, we're going to make x equal 20 and y equal 7. Okay? So if we plug this in on the left side, we get 20 plus 7 all squared. That should equal 20 squared plus 2 times 20 times y, which is 7, plus y squared, which is 7 squared. Okay? So the left side, we get 27 squared, which is exactly what we want, since that's what we're solving for. We're solving for 27 squared, so we needed one side to equal 27 squared. Okay? Now on the right side, we have 20 squared. That gives us 400. And we know that because 2 squared is 4, and we're left with 2 zeros, so we get 400. Okay? And then we have 2 times 20 times 7. 7 times 20, this right here, is 140. And 140 times 2 is 280. And lastly, we have 7 squared. 7 squared is 49. And now we can kind of see why we chose the 20 and the 7. That's because finding the square of 20 and square of 7 is relatively much easier than trying to find the square of 27. So we chose those numbers to help us solve for 27 squared. Okay? So now all we have left to do is to add everything on the right side. And when we do, we get 27 squared to equal 729. 400 plus 280 plus 49 is 729. So we stop here because all we wanted to know was what is 27 squared. In this case, 27 squared is 729. Okay, for number 2, we're going to do something similar, except we're using a different identity. In this case, we're using a difference of squares identity, and we're going to use it to help us find the product of 37 and 43. Okay, so we're multiplying 37 and 43, and we're going to use this identity to help us solve for it. So we're going to choose an x and a y term that helps us make this left side right here into 37 multiplied with 43. Okay? So we're going to choose an x and a y term that helps us get that form on the left side, and at the same time is easy for us to square, because the right side we're just going to be squaring the x and the y term. And in this case, we're going to use 40 and 3. Okay? So if we plug in 40 and 3 into this equation, we get 40 plus 3 multiplied with 40 minus 3. That should all equal 40 squared minus 3 squared. So on the left side, we get that 43 multiplied with 37 that we wanted. That's exactly what we wanted, because that's what we're ultimately solving for, the product of 43 and 37. And that all equals 40 squared. We can do the same thing we did with 20 squared. 4 squared is 16. And we're left with 1 0 on each 40, so we can just add them to the end. So 40 squared is just 1600, and 3 squared is 9. All right, so all we need to do is solve for 1600 minus 9, and when we do, we get that 43 multiplied with 37 gives us 1591. So 43 times 37 is 1591. All right, let's go on and do our last identity. We have x minus y squared. That equals x squared minus 2xy plus y squared. That's our other perfect square identity, but with a negative for our middle term instead of a positive. And we're going to use this to help us find the square of 18, or 18 squared. So very similar to number 1, we're going to choose an x and a y term that on the left side gives us 18, and at the same time is easy for us to square. Okay? So in this case, we're going to use 20 and 2, because when you plug in 20 and 2 on the left side, we get 20 minus 2 squared, or in other words, just 18 squared. 20 minus 2 is 18, 18 squared. And that's exactly what we're solving for. It's what we need to figure out. Now on the right side, we get x squared, or x is 20, so we get 20 squared minus 2 times 20 times 2. Added with y squared, and y is 2. So now we have 18 squared equals 20 squared minus 2 times 20 times 2 plus 2 squared. Okay, we know that 20 squared is 400, so we'll just bring that down. 2 times 20 is 40, 40 times 2 is 80, so you have 400 minus 80 plus 2 squared, or just plus 4. So we get that 18 squared equals 400 minus 80 is 320, and 320 plus 4 is 324. So using that polynomial identity, we can get that 18 squared equals 324. All right? So that's how you use these polynomial identities, how to solve the problems, and at the same time, how you use them to help verify, or sorry, how you use multiplication of polynomials and addition of polynomials to help you verify that these polynomials actually, or polynomial identities actually exist. Hopefully this helps, guys. Have a nice day.